Hi and good day everyone. For this video, we will discuss the different types of loads, its importance, and also how to estimate this factor in AB structure design. Okay, so let's get started. We already discussed in our previous course about the types of loading, like concentrated or uniformly distributed, but we did not discuss the source of these types of loading. So this time, we will discuss it and we will call it in general as structural loads. Let's start with the relationship between loads and structures or buildings. The purpose of a building is to provide a desired environment. Structural design of a building begins after it has been decided that a specific environment is to be provided. Design means the selection of members and materials that will accomplish the desired task in a reasonable and efficient manner. With this, structural components must be selected that are strong enough to withstand the force or loads that will be imposed to them. Thus, it must satisfy this equation that load must be less than or equal to resistance. So what does it mean? It means that if the load effect exceeds the resistance, then the structure will fail. Neither side of the above equation can be determined with absolute certainty. Therefore, the designer must be willing to assign a risk factor to the solution. The nature and significance of the various types of loads that act on a farm building must be assessed, and this information related to decision on design, materials, and construction method. Risks are minimized by the use of the most accurate estimates available. Forces are imposed on building members by nature. Can be wind, earthquake, snow, and also can be man's activities. Some of these loads will have an extreme value sometimes, and to minimize risk, some designers use the extreme value in their design. But economically speaking, we cannot justify designing buildings to resist loadings with a small chance of occurrence. And also, it should be noted that even the attempt was made to design for the ultimate loading, failures still might occur because of a construction error, hidden defect, or even a mistake in design. Now, let's proceed to the different types of load. There are three general types of load. We have the dead loads, live loads, environmental loads. Let's start with the dead loads. Dead loads are vertical and changing loads and include the weights of the material used in constructing the building, such as the concrete in the footings and foundation, and the lumber and other material used in frame, floors, roof deck, and permanently installed plumbing, heating, and electrical equipment. Loads are an integral part of the structure, which means they are permanently stationary and stationary. To estimate dead loads, it should be based on the actual members used. However, it requires an analysis to first determine the member size. Thus, it's convenient to make an initial approximation. After estimating After estimating the size of the structural member, you can use the table provided by the American Society of Agricultural Engineers or other published materials. Okay, let's take a look with this table. You can see the table provides the different types of material commonly used in structures, including their density and unit weight. By unit analysis, in order for us to determine the weight of the materials, we need either the surface area or the volume of the material. Then by simple multiplication, we can get the weight of the material. Let's move another type of loads, which is the live loads. Live loads are estimated based on the expected use of the building. Live loads may be concentrated, uniform, stationary, moving, or impacting. I know that you already know the difference of these terms. The loads may be act on the floor and or the walls. The design load may be vary depending on the structural component being considered. Okay, to understand it, we will look at this table that shows the different farm animals. As you can see, there are two types of flooring. We have solid floors and slatted. And so depending on the design, The loads also vary together with the types of animals. Again, by unit analysis, you just need the total floor area in order to estimate the live loads. The last type of loads is the environmental loads. Weather or natural occurrence often result in load or stress on the building. So some example of environmental loads include snow, wind, earthquake, and hydrostatic soil pressure. Example of these loads. So environmental loads, weather-related loads are estimated based on the probability of occurrence of an extreme weather event. Point to consider. The weather data used and determine the probability of extreme and measured only at a specific location. Second one, the actual occurrence of the event does not necessarily mean the building will fail. Third one, the occurrence interval associated with risk classes are in two-way related to expected building life. Okay, so this is now uh, the type of environmental loads that we will discuss. First is the no. First is the wind loads. Wind loads are important particularly in the design of large structures such as tall building, radio towers, and long-span bridges. And for structures such as mill buildings and hangars, having large enough open interiors and holes which are opening may occur, the wind velocity that should be considered in the design of the structure depends on the geographical location and the exposure of the structure. Okay, so this is how you will illustrate the wind loads. So this is the illustration. You have this structure. So we have windward roof, how it is being illustrated sa wall. Then you can measure using the document formula that Pn or the wind pressure is 2p sine theta over 1 plus sine squared theta. So P is 0.0073 V squared, in which V is the wind velocity in kilometer per hour. Then you have the wind pressure here in Pascal. Okay, so you also have this combination of loads. Only dead loads will always be imposed on the building. However, several of the loading types may act simultaneously. The design analysis should be considered the combination of load types and select structural members which can withstand the most adhered condition. Okay, next, load factor. Load factors are number almost always larger than 1 that are used to increase the estimated loads applied to structures. The loads are increased to attempt to account for the uncertainty involved in estimating their magnitude. Okay, so it is really important to consider load factor because we're just estimating the uh, loads. So in order for us to take out the uncertainties, we will use this load factor. So load factor for dead loads are much smaller than the live load and environmental loads because we can estimate the magnitude of dead loads much more accurately than we can magnitude of those other loads, because dead loads is integral part. We just need the size or the surface area of our structural elements, then we can calculate now their weight. Then by simple multiplying the gravity, we can calculate force the force of exerted by that structural member. Okay, so this is the formula provided by ACI standard. So you have, I think, there are 7 formula. So this is the illustration. So U is the design or the ultimate load structure. D is the dead load. L live load. LR roof live load. S is snow load, rain load, wind load. Then we have seismic or earthquake load effects. So we did not show the formula for calculating the earthquake. So we will just utilizing some examples that are in which the earthquake loads, rain loads, snow load are already being given. Okay, I think that's all. You can read the support reading materials I attach. I have given I provide some of examples there, so you can study that. And if you have any questions, you can contact me through my email or through Messenger. Okay, so thank you and see you in our next video.